Today we're going to learn about particle motion in calculus. Let's say we have a problem like this. If the acceleration of a particle is given by a of t is equal to 2x minus 10, and the initial velocity is 9, find a when the particle is at rest on the interval, closed interval from 5 to 12, and b the distance the particle is from the origin. So, let's start with part A. We have to find when the particle is at rest on the interval from 5 to 12. So how do we do that? When do we know when the particle is at rest? Well, the particle is at rest when the velocity equals 0. But how do we find the velocity function? Well, we're given the acceleration function a of t, and so that means that the velocity function v of t is equal to the integral of a of t. Because we know the integral of the acceleration function is the velocity function. So this is equal to the integral of 2x minus 10, which is equal to x squared dx. So it should be a dx after both those. So dx here, which is equal to the integral of 2x minus 10 dx, which is equal to x squared minus 10x. Now, we know that the initial velocity is 9, so that means that v of 0, and then we have plus c over here, so we know that v of t is equal to x squared minus 10x plus c. But what is c? Well, we know that v of 0 is equal to 9, and because we know the initial velocity, which is at x equals 0, is 9. So that means that when we plug in 0 into this equation here, we should get 9. So we get 0 minus 0 plus c, meaning that c is 9. So that means that v of t is equal to x squared minus 10x plus 9. X squared minus 10x plus 9. So, to find out where this velocity is equal to 0, we just have to factor this. So when we factor it, we get x minus 9 and x minus 1. So that means that x is equal to 9 and 1, right? Well, 1 is not in the specified interval, so we can't use 1. So that means that the particle is at rest when x is equal to 9. So the answer to problem A is when x equals 9. So now we have to find the distance traveled by this particle when it is at rest. So we have to find the distance the particle is from the origin, and it should say when the particle is at rest. So we have x equals 9, but how do we find the distance from the origin? And how do we know where x is right now on the y-coordinate? Well, we know that the integral of the velocity function is the position function. So take a moment to go over this because now I have to erase it. So we get, I'm just going to move this part up. X equals 9, and the velocity function v of t is equal to x squared minus 10x plus 9. So, if this is a velocity function, then that means that the position function, or the distance function, p of t, is equal to the integral of v of t dt, or it should say v of x, or v of x, sorry about that. So we have p of x is equal to the integral of v of x dx, which is equal to the integral of 2x, or x squared, sorry, minus 10x plus 9 dx, which is equal to x cubed over 3 minus 5x squared plus 9x plus c. So what is this c? Well, we know that the particle has to start at the origin because it's moving to the right from the origin. It didn't specify that in the problem, but it should have. So we know that the particle started at the origin. So that means that p of 0 has to be equal to 0. When we plug 0 into this equation, we get 0 minus 0 plus 0 is equal to plus c is equal to 0. So that means that c is just equal to 0, and we're adding 0. So we can erase it. So now the position function is x cubed over 3 minus 5x squared plus 9x. So now how do we find out how far the particle has traveled from the origin? Well, to do that, we have to figure out what our bounds of integration were. So we have to go back to what we had over here. So we know that the particle was at rest when x is equal to 9, and we know the origin is at x equals 0. So basically, to find the distance a particle traveled, we have to calculate the integral from 0 to 9 and from 0 to 9. So this, according to the fundamental theorem of calculus, if we evaluate this from 0 to 9, then we get the distance, because this is the distance function, we get the distance that this particle traveled from 0 to 9, because this is all positive. So, when we plug 9 in, we get this would be equal to 9 cubed over 3, which I already had this written out as 486, minus 5 times 81, because 9 squared is 81, which is equal to 405, plus 81, because 9 times 9 is 81. This gives us 81 plus 81, which is equal to 162. So the answer to part B is 162 units. Today we learned about particle motion in calculus. Thank you for watching this video.